Okay, probability, chapter 5 is probability distribution. Chapter 1 through 4 was collecting and describing data and how to figure probabilities of an event. Chapter 5, we will use relative frequencies as probabilities to create discrete probability distributions of all possible outcomes. Chapter 6 is about continuous probability distributions. Knowing the shape, center, and variability of a probability distribution will enable you to make decisions in inferential statistics. So, discrete, let's remind ourselves what discrete random variables versus continuous random variables. Discrete can be finite, countable number of possible outcomes. How many cars, books, etc. Continuous are uncountable possible outcomes, like measured outcomes. They're fractional decimal values. Can't have a half of a car. So discrete versus continuous. All right, so for example, examples of like the number of traffic fatalities in Florida. That is definitely discrete, right? Distance a golf ball travels, though, is continuous, because think about it. You have yards, feet, inches. Time required to drive on any given day is continuous. You have hours, minutes, seconds. Number of ships in Pearl Harbor, 1, 2, 3, 4. Discrete. Okay, your weight before breakfast is continuous. Pounds, ounces, grams. Remember, continuous is fractional decimal amounts, right? Number of Fortune 500 companies that lost money the previous year. You can count them. Okay, volume of gasoline is measured, so gallons, ounces, etc., depending on what you're measuring things with. So let's focus on discrete random variables for a minute. Suppose I flip a coin 4 times. A possible random variable could be the number of heads. If that, remember the variable, what are we looking for? What are we going to write down? I observe these 4 flips. Okay, and the random variable x could take on the value of 0, 1, 2, 3, and 4. That means I found when I flipped 4 times, I got 0 heads, or I got 1 head out of the 4. I got 2 heads out of the 4, or all 4 turned out to be heads. Okay, we can record that. The highway department is going to inspect a portion of 95. A possible random variable could be the number of potholes in a 1-mile stretch. You can make it a y, and it would be 0 potholes in that mile, 1, 2, however many you get. Okay, they're countable. Hospital administrator is interested in the number of beds occupied. It could be a Z, it could be an X, it could be whatever letter you want it to be. And 0 to the maximum number of beds that they had in the hospital. Air America has a policy of routinely overbooking flights because of past experience shows some passengers fail to show. The maximum number of extra tickets they can book is 5. So the X would represent the number of passengers who could not board because there were more passengers than seats. So everything could work out, and there's no passengers that couldn't board, or they could be up to 5 if everybody shows. Okay. So the probability model, let's remind ourselves, is a collection of all possible values of a random variable. The probabilities that correspond to each value, and then this is the reminder part. Probabilities are between 0 and 1. That's 0% and 100%. Okay. And then the sum of all the probabilities are going to equal 1, typically seen in decimal form or fractional form. So discrete probability distribution is a list of all possible random variables together with its probability. Okay, so when we construct a table, we're going to make a frequency distribution of all outcomes possible, find the sum of their frequencies, what happens, we're going to count them up, and the probabilities of each outcome divided by its frequencies, the sum of the frequencies, and then check and make sure that we have 0 through 1 for probabilities and the sum is 1. So for example, probability table, the attendance. Nancy has classes 2 days a week. She attends classes 2 days 80% of the time. 1 day, so that's 2 days 80% of the time. 1 day 18% of the time. No days 2% of the time. What is the random variable for this? What are we looking at? If we make it x, basically number of days Nancy attends class that particular week. So what values could it take on? Well, did she come both days? Or not come both days. So she didn't come any days. She came 1 day. She came both days. Okay. Construct a vertical distribution table. So 0, 1, or 2 days attended. That's the random variable we picked. So if the given information says that she attends both days 80% of the time, so that's that one right there. She attends no days 2% of the time. When you add them all up, you get a 1, right? Or 2% plus 18% plus 80% is 100%, okay? That's all there is to that. So here's another example we had done before, tossing 3 coins. This is your sample space of your 8 outcomes from tossing 3 coins. What would you get? The random variable we're picking is number of heads, okay? So no heads. Well, if you got all tails, that's the only possibility with no heads. So no heads is 0 for x, and the probability of that happening is 1 out of all of these, right? So probability of x is 1 or 0.125, 1 divided by 8. The probability of getting just 1 head, there's 1, 2, 3, that's it, 1, 2, 3. They're listed right there. 1, 1, 1/8 each, which makes them 3/8 altogether, which is 0.375. 2 heads as another thing that could happen out of your 3 tosses, and these are the 3 possible 1, 2, 3 out of your outcomes to get 2 heads. 3 different ways to get 2 heads. 1, 1, 1 of each, which is 3 also. And then there's only one way to get all 3 heads. So that's 1, which is 1, which is 0.125. These all add up to 1, right? These add up to 8/8, which is 1. We're just making sure that our probabilities add up. Notice that these probabilities are not negative numbers. They're not over 1, so they're inclusive between 0 and 1. And then we add them up. They don't go over 1. Okay?